All right, number 16, we're given some AP stat data for the population, and we're told that the grade distribution follows the following percents, and then we're given the number of success in certain categories for a particular high school in the area. This is made up, by the way. It's not accurate, although I'm sure it could be accurate. Okay. So again, let's first figure out what are we talking about here, and we're dealing with 5 different categories, so it's clearly one of the chi distributions, one of the chi squares, and in this case we're dealing with one sample and then a set of expectations with it. So this is just a textbook goodness of fit test. Okay, so for goodness of fit, our null would be there is no significant difference between observed and expected test scores. An alternative would be there is at least one category that is significantly different than expected. Okay. And that's just a standard verbiage for all goodness of fit tests, is that our null is that we don't really expect anything different between observed and expected, and alternative, we just save face and say at least one category is different, maybe more than one. Okay, so I'm going to go to the goodness of fit part of our chart, and type in my observed, and I'll be very careful on how we interpret these numbers. So observed is I saw 16 people that got that score, I saw 21 that got that one, 11, 2, and 0. Okay. Expected, in this case, is not 11.1. That's 11.1% of the total. So I saw 16, and I only expected 11% of the total to actually earn that score. So what I want to do is I want to add up all of my numbers real quick and see what I get. I get 50. Okay. So expected then would be 0.111 times 50, or 11% of 50. So I expected actually 5.5, and I got 16. So that clearly there's a concern there, not in a bad way. All right, then the next one, so equals 0.216 times 50, then equals 0.239 times 50, equals 0.192 times 50, and equals 0.242 times 50. Okay, and so that outlines, I had 2 people get that score, but I expected about 9 people, so I would say that there's clearly a lot of differences in, from what expected versus what the national average is. Okay, so the test statistic is 47.5. Degrees of freedom would be 4. And a p-value, it says 0.000, so it's 0. It's really not 0. There's probably like a number 15 decimal digits out there, but in other words, this is something to get excited about, that the AP test scores are much different than the national average, and we can then go back and argue about whether it's a good different or a bad different, but it's different. So very excited about this. So I'm going to reject the null. There is significant evidence. There is enough evidence to suggest that the test scores are different for at least one category for AP scores on the AP test. Okay. All right, number 17, make sure I have room here to do it. Number 17, until recently, a number of professionals were prohibited from advertising. 1977, Supreme Court ruled that prohibiting doctors and lawyers from advertising violates the right to free speech. The paper should dentists advertise, compared the attitudes of 101 consumers, 124 dentists to the questions. I favor the use of advertising by dentists to attract new patients. Okay, so we're given two different groups, several different categories. This is a good example of a chi-square, and go back to the wording, looking for either the words same or different or independent or dependent. And so right here, it says differed. So that is a giveaway that we're looking at a homogeneity test. Okay, so for our null hypothesis, we would want to say something about, let's see, the attitudes of consumers and dentists are the same in strength, something like that. An alternative is at least one category is different. Okay, so I'm going to go pull up our independence and homogeneity data, which is this right here, and just type in the numbers. I don't have to worry about the totals. It will do all of that for us underneath the hood here. Okay, and what I want is the test statistic, the degrees of freedom, and the p-value. So this stuff right here. So 79.272 for test statistic. Degrees of freedom would be 4. And the p-value, again, is 0. Now, it's not really 0, but somewhere 15 decimal digits out the way, I actually get to a number. So, in other words, when I see this, it's exciting because I actually found an interesting, something I would want to share, that there actually is a difference in how these different groups feel towards this. So I would reject the null, and there definitely is evidence to suggest that at least one category is different. In other words, what does that mean? That means that consumers and dentists don't think alike. They actually have a different opinion when it comes to this particular subject. All right, last but not least, yay. So as you can tell in the data, this is another chi-square test. So I'm just going to come in here and input the numbers. And we'll go fill out the null and alternative here in a second. So 125, 75, and I actually don't need the totals for this. Keep in mind, this will do the totals for us, so you don't need to put the totals in when you're doing your data. That's it, because the other ones are row and column. Okay, cool. There we go. Okay, so let's 1% level of significance. Okay, so normally we do the 5%. We don't actually have to change anything here. It's over here whether or not we get extended. It doesn't really matter because the p-values, we'll get there. Okay, so you can see it right here. Test the claim that the number of course schedule changes is independent of the fee charged. Okay, so our null is, let's see, schedule and fee are independent. And an alternative is that schedule and fee are dependent. Okay, so coming over here, I got a test statistic of 1.099, degrees of freedom of 1, and a p-value of 0.29. Okay, Now, the fact that it said use a 1% level of significance means in order to get excited and want to go tell someone about this, I'd have to have something smaller than 1%. So the fact that I have 29% means my particular sample would happen 29% of the time. That's very boring. I wouldn't want to tell anyone about that. So interpretation-wise, I would fail to reject the null because our p-value is so large. There is not enough evidence to suggest that the schedule and phi are dependent.